Our next video to do with graphing quadratics is called points of intersection. So consider the graphs of a quadratic and a linear function. We've got three possible intersections. It can intersect twice, once, or not at all, as you can see in the three diagrams here. Now, in the middle one, where it's just touching at one point, if the line touches the curve, we actually call that line a tangent to the curve. So to find the points of intersection, we can solve the equation simultaneously. So an example here, find the point of intersection of the graphs y equals x squared minus x minus 18 and y equals x minus 3. Now because they're both y equals, we can just make them equal each other. So it'll be x squared minus x minus 18 equals x minus 3. Because points of intersection are when the two graphs are equal. We just rearrange this, so we'll have x squared minus 2x minus 15 equals 0. So just put the x and the minus 3 to the other side. We now have a quadratic that we can solve. We can factorise this one down to x minus 5 and x plus 3 equals 0, and then we can solve the equations from there. So x minus 5 equals 0, x plus 3 equals 0 with the no factor law, so x equals 5 and x equals negative 3. So they are the x coordinates of the two intersection points, and then from there we just need to find our y values. So you can sub these into either equation to work that out. Obviously I'll use the second equation because it's simpler. So we'll have y equals 5 minus 3, which equals 2. So 1 point will be at 5, 2. And the second equation, it will be y equals negative 3 minus 3, which equals negative 6. So the second intersection point is at negative 3, negative 6. Another way we can do this, consider the curves y equals x squared plus 5x plus 6 and 2x squared plus 2x minus 4, solved by graphing on your GDC. So I'm going to go now to the graphics calculator and show you how you can do that, and then we'll do part B. So on our calculators, to solve these quadratics, what we need to do is we're going to graph them. So I want you to go to your graphing software, then we're going to enter each equation. So first one, we're going to do x squared plus 5x plus 6. Press enter and it will graph that for us. Now I want to graph the second equation, so if you just press tab on your calculator over here, it will come up with next function and we can enter that one in. So it would be 2x squared plus 2x minus 4. Now, what we want to do here is we want to solve these. So we want to find the 2 points of intersection for this graph. So you can see here, we can definitely see one of them right here. But right now we can't see where the other one is. But that's okay. So what we're going to do is, we can do menu and analyze graph, and you want intersection. So this will find where the graphs intersect. If you click on that, now click either side of the first intersection, and you'll see here that the coordinates come up and it's negative 2, 0. To find the next one, we can do the same thing, menu, analyze intersection. Now we know it's going to be somewhere, so we can click this side, and if you carry on across here, we can see, you see how it came up with the word intersection, then that means it's found one. So if we just click, it will zoom out and show us the next intersection point, which is at 556. To solve this quadratics, remember we're just looking for the x values, so it'll be x equals negative 2 or 5, the x coordinates of those 2 points. Now when we're looking at this part B, and it wants us to solve for x, when x squared plus 5x plus 6 is greater than 2x squared plus 2x minus 4. So what I'm going to do here is I'm just going to zoom back into the graph. And so I'm just going to change the window settings to fit the graphs a little bit nicer. So I'm going to make my x minimum negative 5. So we know at the moment it intersects at negative 2. Maximum, we next intersects at 5, so I'm going to make that say 10. Our y minimum, let's go with negative 5 as well. Our maximum, we knew that y coordinate was at 56 where it crossed, so I'm just going to put 60. Now I can see my intersections a little bit nicer on this graph. Now we're wanting to know when this blue line is greater than the red line. So if we look at the graph here, the blue line is above the red line between these two intersect points. Okay, that's when it is greater than, because the line's above. So we can then say that x squared plus 5x plus this is greater than 2x squared plus 2x minus 4 between -2 and 5, when x is between -2 and 5. And that is points of intersection.